Hi, it's Honors Algebra 2, video number 1, Mrs. Kranz. Hi, and this is Zoe. Zoe says good luck with all your online math. This is Algebra 2 Honors video number 1. Mrs. Kranz, in case you forgot who your teacher is. We're going to start something brand new. Chapter 10, conic sections. All right, we have been through chapters, let's see, 1, 2, 3, all about linears and systems. Chapter 4, quadratic. Chapter 5, polynomials. Cubic, quartic, quintic. Then we did radicals. Then we did exponential, logarithmic. We just finished chapter 8, which is rationals. We will do sequences in series most likely next. But now we're on chapter 10, relations and conic sections. We already did a lot of chapter 11. We did chapter 12 on matrices. All right, so conic sections. Again, chapter 10, the beginning, 10.1. I plan to post the video on April 7th, 2020. Honors Algebra 2, Mrs. Kranz. Welcome. So I plan on posting videos once every couple days and giving an assignment once every couple days going forward. We'll see if that ends up working out. All right, we are going to talk about conic sections today. There are 4 conic sections. Now this is really a lot of geometry, but it's typically covered either in an Algebra 2 course or definitely in a pre-calculus course, so you'll learn this again next year. Conic section is a curve, all right, that's formed by the intersection of a plane, a flat plane, and a double cone. All right, so you see the double cone and then you see this plane running through it. Double cone, plane running through it. All right, so now depending on how the plane runs through, you get one of 4 conic sections. This first one, I think you can look at that shape and tell me what that is. I think you could see, Maddie, did you say? Circle. That's where you run the plane parallel with either of the circles for the cone. All right. Next, all right, if you run the plane, as you can see this way, through either the top or the bottom cone, you will get something you're very familiar with, parabola. All right. Now, if you run the plane, as you see here, all right, through both sides of the cone, you get an oval, a perfect oval, which is called an ellipse. Okay. And the 4th conic section actually has 2 branches. All right, now you're running it perpendicular. The plane's perpendicular with the cones. You get 2 branches, and they kind of look like parabolas, but they are called hyperbolas. How do you get a hyperbola? So here are your 4 conic sections. All right, now we're going to look at graphing these and talking about the conic sections. All right, first problem, and again, you won't have these note pages. I'm going to post these completed for you, but if you want to, work along with me on a piece of graph paper or just want to watch, that's fine. Okay, so here we have our first example. X squared plus y squared equals 16. Okay, these are all going to be squared. So if you're looking to classify these, they're all quadratic. Okay, as you know, parabola's quadratic. All right. This is a plain old circle. A circle will have an x squared and a y squared. Okay. Parabola will have an x squared or a y squared, but not both. All right. Circle has x squared, y squared. But so does ellipse and so does hyperbola. So how do we know the difference? If it's a circle, the coefficients in front of the x squared and y squared will be the same number. Okay. So this is a circle. All right. The center is 0, 0. And the radius, this is r squared, the radius is going to be 4. Okay? To graph this, now you could graph this on your graphing calculator, and when you graph on the graphing calculator, you have to solve for y. So first thing we would do is, what do you think, Kevin? I know you know. Subtract x squared. Second step, opposite of squaring, use square root. So y equals positive and negative, don't forget that. The square root of 16 minus x squared. Right? So now you could put that in your calculator. Right? You could get it out, graph it. You can put in the square root 16 minus x squared, and then negative square root 16 minus x squared. There is no positive negative button on your calculator. All right? Then I don't know what your window is. Mine's typical, negative 10 to 10. And I hit graph. The positive part is the top part of the circle. The negative part's the bottom part. Now this does not look like a nice circle. It kind of actually looks like an ellipse. It is not an ellipse. Okay? It's just because you've got a rectangular graphing window that it actually looks like it's not a circle, but it is. Okay, I think you can see 4, 4, negative 4, negative 4. It's a perfect circle. All right, so let's try. All right, the radius is 4. All the way around. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. All right, then you've got your circle. Just do the best you can. You don't have to get out any protractor or anything to draw this. Just draw yourself a circle. That's not very good, but that's the best I'm going to do for now. All right? So what is this? This is a circle. All right? That's the ground. Lines of symmetry. All right? What do you think? Of course, y-axis. Of course, x-axis. But also y equals x. Or y equals negative x. Right? Basically, for a circle, you have an infinite number of lines. But not any old line, like that line is not a line of symmetry. They have to go through the center, right? Through, in this case, 0, 0. Right. Infinite number of lines of symmetry. The domain x goes from negative 4 up to 4. Negative 4. Range, same thing, negative 4 up to 4. And this is the circle, the most basic of the 4 conic sections, and we'll spend a day on each one. All right, now, second example. 4x squared plus 25y squared equals 100. Okay? I have an x squared and a y squared. All right, so I know it's not a parabola. Right? I also know it's not a circle because the coefficient numbers are different. Here's a 4, here's a 25. Right? Lastly, if it's a plus and the coefficients in front of the x squared and y squared are different, this is going to give you an ellipse. Okay? All right. How are we going to graph it? Well, we're going to solve this thing for y. All right, so the first step is subtract 4x squared. Second step, divide by 25. Third and final step, opposite of squaring, use square root. And positive, negative. Okay? So this is going to graph as an ellipse. All right, so I got to put it in the calculator and put in the positive and the negative. I have to put them in separately. So I've got parenthesis 100 minus 4x squared, parenthesis divided by 25, parenthesis, top half. And the same thing, negative. Now, to save myself a little bit of work, I'm actually going to go negative VARS, y variables, y1. So that'll do the opposite of what I just put in for y1. All right, let's make sure I got it in there. And we're going to graph. Okay, there we have an ellipse. And there's the top half, there's the bottom half, closed up. Okay, now, what do you think? Let me change my window, I'll go by ones. Can you see what are the x and your y intercepts? All right, we got 2, negative 2, and 1, 2, 3, 4, 5. And -5. So I've got 1, 2, 3, 4, 5. 1, 2, 3, 4. -5. 2. -2. Here's the ellipse. It's like an oval. Perfectly symmetrical. All right, around what? What are the lines of symmetry? Well, we've got y-axis and x-axis. That's it, okay? You have the x-axis, and you also have the y-axis. Or y equals 0, x equals 0. All right, domain, x gives from -5 up to 5. Range, y goes from -2 up to 2. All right. Here's an ellipse. Okay. Next, what is this going to be? All right. Is it going to be an ellipse like the last one? It's going to be a circle like the first one. Not a parabola because it has an x squared and a y squared. All right. Well, what am I going to do? I could add the 1. All right. Now I have this. All right. I have a y squared, I have an x squared, just like last time. But now, instead of a plus, I have a minus. A minus in the middle, whether the y squared is first or the x squared is first, always gives you the hyperbola. Not letter. Hyperbola. Okay. So, how are these going to graph? Well, let's put it in the calculator. I have to solve for y. So I'm going to add the 36x squared. Right, divide by 4. And square root. Big square root. Okay. Positive and negative. Okay. So now what? I'm going to adjust what I've got in here. Now I've got 36. Let's see what I'm doing here. 36x squared plus 1 divided by 4, and the opposite of that. Let's grab it. 2 branches. There we go. And if I hit trace, I can see the y-intercept is 0.5. Okay. This will be perfectly symmetrical, so the bottom will be -0.5. All right, so I've got 0.5, -0.5. Now, it kind of looks like a parabola, but it is not, and we'll talk about it. These hyperbolas have 2 branches. Okay. And they will actually have, we'll draw them in, but not on this one. I'll draw it in. This is just a sketch. They're going to have what are called these slant asymptotes. Okay, and we'll figure out the slope of those lines and everything. Right. But you've got your 2 branches. You're going to have pointing up and down, or you can have pointing to the left and to the right. That is hyperbola. Okay. Lines of symmetry, you've got your same, your y-axis, your x-axis. So the x and y-axes. Now, what's the domain on this? Can x be anything? What about x here is 0, x here is like 1, x here is 2, x is negative, x can be anything, all real numbers. Okay. Not the range, though. Y is greater than or equal to half, or bottom part, less than or equal to -half. There's your range. Okay. All right. Now, lastly, we're not going to graph. We're going to look at 4 equations, figure out circle, ellipse, hyperbola, or parabola. Which one? Okay. Well, x squared, y squared means it's one of these 3. Okay. Minus in the middle, hyperbola. Automatically. Doesn't matter what the coefficients are. Okay. 2, x squared, y squared. All right, so parabola's out. All right. Plus in the middle, hyperbola's out. circle or ellipse. Look back up at ellipse. Coefficients are different numbers. Here, coefficients are same number. If I divided this all by 6, I'd get x squared plus y squared equals 100. This is your basic circle, the most basic conic section. All right, center at 0, 0, and the radius would be 10. Okay. 3 plus x squared, y squared. So it's not a hyperbola, not a parabola. Coefficients are different, right? Different coefficients. So this is an ellipse. All right, last one, x squared and y squared. All right, so it's one of the three. Minus in the middle, hyperbola. Okay, well, what about parabola? Well, this would make it a parabola right there. All right, you have only a y squared, okay? Or if you have only an x squared, but this guy added on would be a parabola. All right, so this is basic intro to conic sections. Hopefully this makes sense. Please let me know if you have questions, and that's it for video number 1. Thanks.